Mitigate climate change. It's going to be given by our keynote speaker today, Tanishq Abraham. First, a little background on Tanishq. He's currently a college student at American River College, and in 2 weeks will be inducted as the youngest member of the Phi Theta Kappa student organization in the history of the college.
Wow.
Yeah, it's quite an honor. Also, he is the founder and vice president of the American River College Astronomy Club, and is a member of the Peninsula Astronomy Society. And he's also been a special medical correspondent on the CBS TV show, The Doctors. Just a sidebar is I had Tanishq as a student in physical geology lecture and physical geology lab, and he was one of the top students in the lab and the top student in the lecture. But that was a long time ago when he was 8. So, with that, Tanishq.
Thank you for the introduction, and thanks for having me again. My topic will be about something that's been in the news for some time, and something that concerns me, climate change. So here's a little overview of my talk. I'm going to first talk about what climate change is and global warming, and the effects of climate change and measuring climate change. Then I'll delve into the technological solutions for climate change, and then we'll have a question and answer session. So what is climate change? Climate change is basically changes in the average temperature, precipitation, wind patterns over long periods of time. And when I say long periods of time, I mean probably about several decades to several centuries. So really long periods of time. And climate change is caused by natural causes and human causes. So it can be caused by changes in the Earth's tilt, changes in the solar activity, and also natural changes in the greenhouse gas concentrations. And of course, some greenhouse gases include CO2, methane, nitrous oxide, water vapor, tropospheric ozone, and the F gases, which are basically gas like chlorofluorocarbons. So after the industrial era, humans started contributing to the increasing effect of climate change, and so we started adding billions of tons of greenhouse gases, especially CO2, into the air. And yeah, the atmospheric CO2 concentrations has increased by about 40% since pre-industrial periods. And in the 18th century, we added about 280 parts per million by volume, or ppmv. And in the 21st century, in 2010, we released 390 ppmv. So this is a lot of CO2. And in fact, the current CO2 level is higher than it has been in the in 800,000 years. Oh, this thing got kind of messed up here. This is a graph showing the values of carbon dioxide, methane, and nitrous oxide. And as you can see here, when the pre-industrial period started, the concentrations of these gases rapidly increased. So then, what is global warming? Global warming is basically a term used for climate change in the media. It's actually an effect of climate change, and it refers to the recent and ongoing rise of the average global temperature of the Earth. And since the early 20th century, the average temperature has increased by 1.4 degrees Fahrenheit. And according to the Intergovernmental Panel of Climate Change, the temperature may increase about 2 to 5 degrees Fahrenheit for the lowest emissions scenario, meaning that not like releasing a lot of greenhouse gases, and 4 degrees Fahrenheit to 11.5 degrees Fahrenheit for the highest emission scenario. So that will happen if we release a lot of greenhouse gases, and it is caused by the increasing concentrations of greenhouse gases, especially CO2. And it's due to human activities, and also by burning fossil fuel and deforestation. And every year we release about 30 billion tons of CO2 into the atmosphere because of human activities. So even though we've only increased the average temperature by 1.4 degrees Fahrenheit, there are some observable and considerable effects that we see today. The first effects usually occur in the polar regions and in the higher latitudes. Ice loss and glacier shrinkage are one of the first effects to be seen. In this photo, you can see this is in August 1941, and this is in August 2004, and so this glacier, known as the Muir Glacier in Alaska, has shrinked a lot, or retreated a lot, and it produced this beautiful lake. And this is actually in about 60 years or so. But you can still see the glacier over here, but a lot of the glacier has shrinked. And here is actually a photo showing the ice loss, and here this is how much ice there was in 1979, and you can see that a lot of that ice has shrinked by 2007. So there are also other effects seen today, like a rise in sea levels, and this leads to flooding of coastal areas and disappearance of coastal areas. And also there's an increase in environmental temperature, and so there'll be more frequent hot days and nights, which we all know. We do not like hot days and nights, but this is a good excuse for the kids to have ice cream. It also increases the global area affected by drought, and this leads to changing forests, because there will be more dead trees and more frequent forest fires. And also there will be more intense and frequent tsunamis. And last but not least, the period of El Niños has increased, and El Niños are basically periods in which the average temperature of the Pacific Ocean increases, and due to geological processes. So what's happening is these periods are getting longer and longer. So the average temperature of the Pacific Ocean is increasing. So what are the effects that could occur in the future? One of them includes more thunderstorms and more tornadoes. So what's happening here is that thunderstorms and tornadoes need something known as connective available potential energy to this energy is used to create tornadoes and thunderstorms. And because of climate change, there is actually more connective available potential energy, leading to more intense thunderstorms and tornadoes. And other effects that could occur in the future include the emergence of new diseases in new areas, like the West Nile virus, and species extinction due to the high temperatures, changing range of diseases, reduced tourism, because let me give you an example. For example, like in ski resorts, there is actually snow, and that snow melt because of climate change. So people won't be able to ski. So therefore, there'll be a reduced tourism. So that's one way there's reduced tourism. And there'll also be culture changes because mostly in the Arctic, where the Inuits and Eskimos live, because what will happen is the ice will melt, so they'll need to adapt to their to their environments, and their culture will change. And this one is an interesting effect: increasing crop yields. Usually, all the effects are negative effects, but this one is actually a positive effect. So how can we measure? How do scientists measure climate change? Well, they can use historical data like ice core studies and ocean sediment cores and tree rings. Here is actually a graph. All this data was obtained from ice core studies, and as you can see, the carbon dioxide concentrations fluctuated but never went above 300 ppm. But the value for carbon dioxide concentration for 2008 was close to 400 ppm. It dramatically increased here, and these are the values of carbon dioxide concentrations for 2100. We can also obtain current data using satellites. For example, one of NASA's spacecraft known as Aura takes data of carbon dioxide concentrations and also the global average temperature. Okay, so what can we do about this problem? We can use solar radiation management, or SRM. We can store this carbon dioxide in the earth. We can use ocean fertilization, engineered weathering, green technology, and nanotechnology. And I'll go into more detail for every single one of these. Okay, so one way we can do solar radiation management is by using stratospheric sulfur aerosols. So what happens is we produce billions of tons of sulfur dioxide and sulfuric acid. Then we send this sulfur dioxide or sulfuric acid to the stratosphere using jets or balloons, and this sulfuric acid or sulfur dioxide will change into sulfate, and sulfate will reflect some of the sunlight. The major problem is we don't know what will happen, like what the effects will be. We don't know whether the precipitation rates will decrease or whether the ozone degrades. We need experiments to figure this out. But the problem is the government is hesitant to approve these experiments. So that's the major problem. We can also use solar shields, and basically they are clouds of cylindrical lenses that actually deflect some of the heat away, and the cloud is basically half the diameter of the Earth, and it's located at this point known as the Lagrange point. Oh, what happened there? Lagrange point over here, and it is a very fast way to reduce the effects of climate change. And according to computer models, the temperature will decrease for about 2 to 8%, and it actually increases plant growth because some of the light will be diffused, and so what will happen is the plants will also get light even in shady areas. So what will happen is you can also plant your trees in shady areas. We can also store carbon dioxide in the earth by burial, and so so we just basically bury the carbon dioxide in geological formations or rocks. But the problem is there is a risk of earthquakes, so because of the high pressure. And we can also use reforestation, in which this is actually a method which we plant new forests that actually can effectively absorb the carbon dioxide. And with the help of agriculture, we can also plant trees and plants that will again absorb the carbon dioxide effectively. We can also store carbon dioxide in the oceans by dumping it into the oceans or by injecting it into the oceans. The problem is it's expensive, and as I said with burial, there's a risk of earthquakes and tsunamis, and so more research is needed. So another method or proposal to help address this problem of climate change is by using ocean fertilization. So in this process, what happens is we scatter iron in the oceans, and iron actually boosts the growth of phytoplankton, and through photosynthesis, these phytoplankton will absorb the carbon dioxide. So this is kind of like a fertilizer. And the drawbacks is the experiments show that they are not effective. Experiments done by Stanford and Oregon State University show that when the natural plankton bloom, what happens is less carbon dioxide is absorbed. So something is wrong with this system, and so more research is needed. So another method of mitigating climate change is by using engineered weathering. So there is this process known as silicate weathering that occurs in the oceans, in which carbon dioxide is absorbed by the oceans, and the carbon dioxide changes into carbonic acid, and the carbonic acid becomes neutralized in a reaction with the silicates on the oceanic rock, and this actually also produces carbonate salts that will increase the alkalinity of the ocean, and this helps the ocean absorb carbon dioxide. But we can also chemically alter the oceans by replacing the carbonic acid with hydrochloric acid, and this will actually increase the alkalinity more than what carbonic acid can do, and so it can help the ocean absorb more carbon dioxide. So it basically increases the ability to store carbon dioxide in the oceans. We can also use green technologies like hybrid electric, CO2, ethanol, and water-powered cars, algae biofuels, which are biofuels created from algae that are fed water and carbon dioxide, and biochar, which is produced when we burn plant waste in an oxygen-free environment in a process known as pyrolysis. And in this process, it doesn't let the carbon dioxide escape. So it's a nice process, and you can actually create plastics out of it and use it as fuel and also as a fertilizer. So another tool scientists can use is nanotechnology. Nanotechnology is like a platform technology. So by itself, it cannot create a big impact on climate change, but when we use it and incorporate it into larger systems, it will have a great impact on climate change. We can use it in the production of hydrogen, like in this process known as electrolysis. We separate oxygen and hydrogen from water, and we can use this hydrogen in hydrogen cars, and this process requires a catalyst that would speed up the reaction. If we use a nanoparticle catalyst, then we can get more hydrogen, because more surface area more active the catalyst will be. And nanoparticles have a big surface area. And so in that way we can produce more hydrogen. We can also use something known as carbon nanotubes, which are these very, 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 very small tubes shown here for storing hydrogen. We can also create nanoparticle silicon systems and mimic photosynthesis, so we can get solar energy. And we can also create catalytic converters. Like how I said before, if you use nanoparticle catalytic converters, you'll have more surface area, which means more active catalytic converters. The problem is we don't know whether it's safe or not. We need more experiments and to long-term experiments to see whether it's safe for humans and if there is a health risk. So here is a chart showing some of the ways nanotechnology can be used. And I talked about hydrogen generation, carbon nanotube storage. We can also use it for catalytic converters. We can create a molecular solar cells, and we can create better batteries out of nanotechnology. And we can use things like nanogels, so the heat for insulation in buildings and homes, so the heat won't escape. Look, I don't know. There was something here. It actually meant to say we can help too in simple ways. So all of us can also help to reduce climate change. One way is by using the 3 R's: reduce, recycle, reuse. And we can instead of driving your car, you can ride a bike, walk, and carpool, or use public transport when possible. And you can use green technology vehicles like hybrid cars and electric cars. And if you have a diesel car or a diesel engine, you can create a biofuel and you can power your car with a biofuel. So that's cool. And you can also use higher fuel efficiency and smaller cars. And you can also start a petition to fund climate change experiments. And of course, the most important one, of course, is to conserve and save energy by using energy efficient light bulbs, especially LED light bulbs. They are very energy efficient. And switch off lights when you're not in the room, and set the thermostats to a lower temperature. So, well, I had so many references, so I couldn't list them all, but questions?
I have one. Has there been any estimates of the CO2 emission from volcanoes?
Well, that does actually that does have has an impact on the climate change, but they probably do also measure that when they're making all these graphs, but I think the graphs I was showing are actually are actually for human emissions. Not everything. It's just human emissions. And there was that graph before that I think which one? I think it was all the way behind here. This one. This one is based on ice core studies. So this one will probably include the volcanic eruptions, but I think all the other ones were basically just on human emissions. Any other questions?
Can you flip back to the stratospheric reflection one? I'm just curious about the Lagrange point.
Oh, this one?
No, the Lagrange.
There you go, right there. Actually, do you know how far out that is?
The Lagrange
I mean,
point.
is that the scale, you know, I mean, is it like?
This
you
is
know-
not, this is definitely, not in scale, I mean, this is not in scale at all. It's, the sun is, probably way out here, probably all the way there, but, this is not in scale, and Lagrange point.
We're looking at the top right, and you got the L1 distance, you got the Earth there, so is that, I mean, is it like 7 or 8 Earth distances out, is that like the Lagrange point, or is that not the scale, so maybe actually be further out?
Well, yeah, it's probably, a little further out, if you, wanna use this scale, the Lagrange point would be somewhere around there, and the sun would be a little farther away, but, this is definitely not in scale,
Okay.
so.
So I was interested in your different technologies you're proposing. This is something I'm very interested in as well. Now, the carbon sequestration is actively being done in Missouri right now. They have a lot of limestone and they have a lot of space for that, and it's been a big push. Do you know if on the ocean suggestions of adding the different chemicals to the ocean and the HCl and all that, have that all been modeling, or are they doing some tank studies? They haven't actually done anything in the real ocean yet, right?
Yeah, they've not done anything in the ocean, which is, they've never done anything in the ocean. They've probably done like tank studies like that, but they've never done anything in the ocean. But I don't know whether it would be in years, because hydrochloric acid is kind of dangerous to the marine life forms. So I don't know whether it will be useful, but they've never done it in the ocean. So
I want to attach onto a point you just made. A lot of these different suggestions for mitigating climate change are very artificial, and even though it would be useful to have experiments to know what it would do, I mean, it is, out of all of these, is there one that you would recommend over the others for the least amount of chance of hurting more than it could help? Is there like, out of these, do you have a favorite one that you like more because it's only mostly good and no bad?
let's see. Well, yeah, the first two ones, which was the solar shield and the stratospheric sulfur aerosols, I like, but this one as I said, but both of them they don't know the effects. But I'm thinking that it's probably not going to have very bad effects on the Earth, because like this one I said, it only decreased the temperature by 8%. It's not going to decrease the temperature like dramatically, but at the same time it's also helping out. So I think the solar shield would be of good use, and this one I kind of like too, but we don't know the effects. We need experiments. So this one I don't know.
What about nanotechnology?
The solar shield.
And also the nanotechnology too. Nanotechnology can also help a lot, and green technology. But this one and this one, it's probably not very useful. But the other ones are probably better than these two ones. But
This is more of a comment than a question, but you mentioned the changes in the Arctic areas and the culture. And I went to Greenland a couple of years ago, and the changes are already there. The Inuits that you talk about that are dependent on the sea mammals are having a problem finding them enough, and they're having to change the way they eat. They're eating beef for like the first time and spending $13 a pound on it. It was everywhere I went in Greenland. It was what they were talking about. Climate change. This is very pertinent right now to people in the northern climates.
any other questions or comments?
I was just curious, What's your opinion of things like the Kyoto Protocol and this concept of carbon credits that California is pursuing? Do you think that that is helpful, or?
I haven't heard of those technologies.
The Kyoto Protocol is like an intergovernmental agreement on trying to target, I think, CO2 emission levels from like 1990 as a base year, and trying to get emissions back to those levels. And carbon credits is a concept where people that emit carbon have to pay for credits for the right to emit, and you get offsets for things like plantations and things like that.
Well, that would actually kind of motivate us to stop emitting carbon dioxide. So it is kind of useful. So.
Any other questions? Thank you very much. Really had a
Thanks for
great. At this point, I'd like to introduce our Chief of Geological Services here in Sacramento, Dot Lofstrom, and she'd like to say a few words.
Thank you again for coming here. That was an excellent talk. Oh, there you go. And to be ready for that one. And you know, like I said, this is a particular interest of mine, and everyone in here is an environmental scientist or engineer or geologist, and so we really appreciate your insights. And we have a certificate of appreciation for you. And
Thanks.
And I can't wait to hear what you're going to talk to us about next year. So thank you.